Welcome to this course on climate change science. I am Professor Srinivasan and I have been talking about climate change for the last 40 years, and I find that many people are climate change skeptics. They don't believe that climate change due to human action can actually occur. So this course is meant for you to understand the complexities involved in climate change science and for a clear understanding. Climate change will be the most challenging problem that will be faced by human beings in this century. So, the objective of this course is to enable students to understand the various components of the Earth's climate system that contribute to changes in Earth's climate. The main focus will be on a quantitative understanding of the factors that contribute to global climate change. You can convince others about climate change only if you make a quantitative statement. So, what will you learn in this course? First is, how do we know that human beings are contributing to global climate change? Because many people have doubts whether human beings can change the global climate. The next important issue is Earth's climate stable? Because there are concerns that climate change may push the Earth's climate to some other state which is not favorable. Okay? Now, one of the doubts a lot of people have is, why do gases whose concentrations are in parts per million can have such a large impact on Earth's climate? So, this will also be clarified in this course. The other important thing to understand is the role of water vapor. Water vapor plays a very important role in Earth's climate, and it is important for you to understand its role. Now, there are many positive feedback in the Earth system which causes the climate to change rapidly. You need to understand them and also know what is known as tipping points, which suddenly change the climate from one state to another. You also should learn why Earth had ice ages every 100,000 years in the past. This is what we call natural climate change. Climate change occurred in the past due to natural causes. And you also know that once upon a time, Earth was completely covered with ice, which was called snowball Earth. Okay? These are some of the topics that we will cover. Now, you must remember that when you talk to other people, people have various excuses to deny climate change. For example, for a long time people said there is no global warming because we have not accurately measured climate over the entire Earth. And when it was shown that global warming is occurring, people said maybe it is natural, maybe it is not humans who are responsible for global warming. When it was shown that human beings do indeed cause global warming, people said global warming is occurring, but impacts will not be large. Then when it was shown that global warming is causing large impacts, people said it will be too costly to mitigate climate change. Many people today believe that climate change will take place, but we cannot do much about it because it will be too costly. So, to respond to these excuses, you need a good understanding about what controls climate change, how we can mitigate climate change in the future. Now, there are many books that you can look up in a Google search, which will tell you that global warming is a hoax. One of the well-known books is by Michael Crichton, a well-known author. He wrote a book called State of Fear. He claimed that the fear about global warming is not real, it is a hoax, and Earth will somehow manage to maintain its climate in a constant state. Okay. Now, there are people like Donald Trump, a well-known politician. Whenever there is a record cold wave, he says it disproves global warming. This is based on a misunderstanding between weather and climate. Weather changes every day. You can have a cold day and a hot day. That does not mean global warming is not occurring. Okay? So, it is important for you to understand and also tell others the difference between weather and climate. Now, last year 2023, the temperature of the earth was 1.5 degrees above the temperature that was there between 1850 and 1900. Okay. Now, it was thought that this will only happen with 10% chance. Okay. Now, in this period we are now, it has increased to 50%. So, already last year we crossed the 1.5 threshold, and so we have to be careful about further global warming. So, what one must realize is that Earth's climate can change rapidly. Okay. A cascade of tipping points can trigger rapid climate change. We will talk about this more detail in the course. Rapid climate change is a low probability event, but if it occurs, it has a high impact on your life. So, we have to worry about it. Okay. So, we already crossed 1.5 limit that was proposed in the Paris Agreement in 2015. We thought this happened 10 years from now, but it has happened last year. So, this is a warning to all of us that we have to take climate change very seriously. Now, when you hear various debates about climate change, you will hear two opposite viewpoints, okay, expressed with equal intensity. Both sides will make strong claims about what they are right. So, many journalists feel that the truth is somewhat in between. That is not true. The truth does not necessarily lie exactly halfway between two extreme views. It is possible that one side is completely wrong. Okay. This is a comment by well-known scientist Richard Dawkins, who argues that we have to look at all arguments very carefully. Do not assume that if there are two opposite views, the truth is exactly in between. That need not be true. Now, we start looking at the global mean temperature. The global mean temperature has been evaluated for the last 150 years, starting from 1850. Okay. You can see that from 1850, the temperature of the earth has increased by almost 1.5 degrees. Okay. And note that this change is not uniform. It was almost constant between 1850 and 1920, then it started increasing gradually, and in the last 60 years it has increased more rapidly. Okay. Now, when people look at this data, they ask this question, how do you know that this is accurate? Because remember that most of the temperature measurement occurs over land. There are meteorological stations where these are measured. Over ocean, earlier the measurements were by ships. They will throw a bucket into the ocean and measure the ocean temperature. But today we get most of the ocean data from satellites. Satellite measure the emission from the ocean surface and convert that into temperature. So, today we have a lot more data from satellites than that was possible before 1960. So, we have more confidence in the data after 1960. Even then, notice that the temperature varies a lot year to year. Okay? This is natural variation, because energy is exchanged between ocean and atmosphere. Some years are hotter, some years are colder. A change about 0.1, 0.2 degree is a part of natural variation. Okay? Now, if you want to know how accurate this data is, before that, let us look at why do we consider the increase in global mean temperature as a metric for climate change. Because none of us live in the global mean. You live in either a city or a village, you would like to know how the temperature changes in that village. But we are using the global mean temperature as a metric because it tells us that there is an imbalance between energy absorbed by the earth from the sun and the energy emitted by the earth. Okay? That imbalance causes the global mean temperature to go up. Now, this imbalance can be on account of human actions, can also be natural changes. Now, if the temperature was increasing in only one part of the world, then you can look for solutions in that part of the world. But we now know that the temperature of the entire world is increasing, and if you want to control that, all governments of the world have to come to an agreement, and for that agreement to be there, we need a global metric, and that global metric is a global mean temperature. If the global mean temperature is going up, then all the countries of the world have to realize that all of us are contributing to that change, and all of us have to take action to control the increase in temperature. That is why this is a metric used by the United Nations. They have an intergovernmental panel on climate change which monitors this temperature, and in the Paris Agreement signed in 2015, the agreement was to try to limit the increase in temperature to 1.5 degrees from the temperature there between 1850 and 1900. That is why we are focusing on that. Now, you might still have a doubt how accurate is the measurement. So, here I have shown you 5 different groups in the world, one NASA in USA, and NOAA also in USA, Met Office in United Kingdom, and a group called Berkeley Earth. All these are calculating the global mean temperature from thousands of data over land and ocean, and they have computed the temperature change compared to the value relative to 1950 to 1980. Okay. Now, you can see that the world was colder before this period, and it became warmer in the last 60 years. Now, notice that the 5 different groups do not agree exactly. There is a difference of around 0.1 degree, which is not surprising, because when you collect data from thousands of sources and you calculate an average, there are various ways of doing it, of taking the mean. So, there are some differences in methodology, but the key message is all of them agree that the temperature today is about 1.5 degree above the temperature between 1880 and 1900. Okay. So, although there are small differences between different groups, all of them are agreeing that the Earth's climate is changing, temperature is going up. So, if any of you had doubts about whether climate is really changing, this should allay your doubts. Okay. Now, here is another graph computed by 6 other groups. Now, the reason this graph is shown is I want you to focus on the period 1860 to 1920. Here you can see there are larger differences compared to the last 10 years. Why? because in the period 1860 to 1920 there was no satellite data, and there are only few ships in the ocean. So, there are large gaps in the data collection. So, the different groups, when they compute averages, they get somewhat larger differences. But as you come to the last 60 years, you can see they are almost in perfect agreement. So, you can see that we have more trust in the data in the last 60 years compared to the data 150 years ago. Now, if you do not believe in global mean temperature, you can look at the consequences of global warming. When global warming occurs, the sea ice starts melting rapidly. Now, sea ice can be measured from satellite in the last 40 years, and you can see that the global sea ice cover has been decreasing quite rapidly from 1979, when you have the first satellite data, to today. Okay? And it declined from around 26 million square kilometer in 1979 to today, 2023, it is 21 million square kilometers. So, we have lost 5 million square kilometers of sea ice in the last 45 years. Okay? So, this is a clear indication that global temperature is warming and sea ice is melting. Now, there is one more example here from just the northern hemisphere sea ice, which is more accurately measured because more human beings live there. And there you can see that the sea ice has declined from around 7 million square kilometer in 1979 to around just about 4 million square kilometers in 2023. So, a decline of around 3 million square kilometers in the northern hemisphere. So, both these tell you that global warming has reduced the sea ice cover. Now, what are the consequences of global warming? One major consequence is increase in sea level. When the temperature rises, ocean temperature rises, then the water expands. Okay? So, you can see that due to temperature rise, thermal expansion has contributed to about 35 millimeters of sea level rise, and land ice melting and the water reaching the ocean has contributed around 20 millimeters, and melting of Greenland and Antarctic ice has contributed around 10 millimeters. So, all put together, the sea ice has increased in the last just 18 years by around 50 millimeters, okay, just in 18 years. So, if this continues, the sea level will rise by almost a meter by the end of the century. Now, if the sea level rises, it has important consequence to people living along the coastline. A large number of people live along the coastline, and they will face serious consequences of this sea level rise. Here is again comparing the role of expansion of sea water and added water from melting of land ice and melting of Antarctic land ice and Arctic land ice. So, total is, you can see that compared to 1983 is almost gone to 9 centimeters. Okay. Now, if you look at a longer period going from 1900 to 2015, you can see that the sea level has risen by around 160 millimeters, 16 centimeters. Okay. And this is, and you can see that sea level rise was gradual in the early part of the 20th century. It then accelerated to 1.2 millimeters per year, and now it is increasing at 4.4 millimeters. So, the sea level rise is accelerating. This is also a warning for the future. Now, if you compare the sea level rise over the last 2000 years. Okay. Some of them are what is called proxy reconstruction based on other sources other than direct measurement. You see that sea level rise in the last 120 years is 5 times faster than the previous 1000 years. So, all this is a warning that climate change is occurring rapidly now than in the past, and also points to the human impact. Human impact is in the last 100 years. Okay. Now, why should you worry about it? You can see the consequence of rapid sea level rise will be many coastal areas will be inundated. Okay. There will be flooding in many coastal areas. Here is an example of what can happen to West Bengal and Bangladesh in the Indian region, which in the future will be underwater because of sea level rise, which is a consequence of temperature increase in the global mean. Okay. So, this is one of the serious consequences of global temperature change. Now, a common misconception is there that carbon dioxide, which is a very minor constituent of the atmosphere, cannot influence climate change. The purpose of this course is for you to understand how a very minor gas like carbon dioxide or methane or ozone can have such a major impact on Earth's climate. This is an unusual feature of the Earth, that the major gases like nitrogen and oxygen do not directly contribute to climate change. It is the minor gases which are contributing. Now, before you get into that issue, I want you to understand the difference between weather, natural climate variation and human induced climate change. These are 3 different things, and a lot of confusion is there among politicians and public because they can't understand the difference between weather, natural climate variation and anthropogenic climate change. Okay. These are totally different things. Now, weather is something all of you understand well, because every morning when you get up, you want to know whether it's going to be clear or whether it's going to rain, so that you can wear the right kind of clothes. Okay. And then you want to know whether you want to carry an umbrella. So, weather is the state of the Earth's atmosphere, temperature, humidity, cloudiness, rainfall, which changes from hours to days. It is a regional feature. For example, the weather in Bengaluru is not same as weather in Chennai or in Delhi, and the main component which affects weather is atmosphere. If I know the state of the atmosphere today, I can predict accurately what will be the weather tomorrow. So, today computer models are predicting weather accurately a few days in advance. You can look up your mobile or on TV, they will tell you what's the weather tomorrow, and they will be fairly accurate. Okay. So, weather is something which changes from day to day, and all of us have to get used to those changes and be prepared for it. Climate is the statistics of the weather, that is the distribution of climate, temperature, rainfall, humidity, cloudiness, how it is distributed in a given area. Okay. And when you talk about climate, we do not talk about today, we talk about averages over months, years and decades and longer. Okay. And climate influenced not just by the local atmosphere, it is also influenced by global changes. Okay. Suppose I want to know what will be the climate of Bengaluru next month, let us say in August or September, then I have to know what is going on in the Pacific Ocean, because the climate in the Pacific Ocean, for example sea surface temperature, will have an influence on the weather in Bangalore 1 month from now. Okay. So, what you must know is climate is influenced not only by the local atmosphere, it is also influenced by ocean all over the world, land, and also by human beings. Okay? So, that is what makes climate different from weather. So, I will give examples for you to understand the difference between climate and weather. So, climate is average of the weather over a certain time period, years or longer, and it is not same as weather. So, this slide shows the difference between weather, which is of the order of hours and days and weeks, climate variability, which is the change in climate from year to year due to natural causes, and climate change, with a long term change in climate, 10 years, 30 years, 100 years, which is influenced by human beings. Okay? So, as you go from left to right, the temporal scale and the spatial scale are going up. Here you are talking about days and weeks, here you are talking about months and a few years, here you are talking about 10 years, 50 years, 100 years. Okay? So, you look at the scale hours to centuries. So, the major concern in this course is about changes from decades to centuries, not what is happening tomorrow or day after. Okay? That is weather. Now, to illustrate the difference between climate and weather, I have taken the temperature distribution in Bengaluru and Chennai, two different cities in India, in the month of June, okay, summer month, averaged over a fairly long period. In this case, there is around 45 years. Okay. Now, you can see that the temperature distribution in Bangalore shows a lower temperature than Chennai. Okay. So, generally Bangalore is colder than Chennai by around 6 degrees. Okay. So, Bangalore has a colder climate than Chennai, but on any given day, you can see this overlap here. On any given day, temperature Bangalore and Chennai can be same. Weather. So, for example, the month of March, Bangalore sometimes is hotter than Chennai, but on an average, Bangalore is about 6 degrees colder than Chennai. So, Bangalore climate is colder than Chennai on an average, but on any given day, the weather in Bangalore can be hotter than Chennai. So, that tells you the difference between weather and climate. Okay. So, Bangalore is cooler than Chennai most of the time, but on a given day, Bangalore can be hotter than Chennai. Now, this graph shows how the Arctic sea ice has come down rapidly in the last 40 years, obtained from climate data. And in this, we show the difference between long term climate change, the blue line, and the year to year climate, which is the black line. The black line is an indicator of climate variability. Year to year climate is changing. Every year, Arctic sea is not decreasing. There were years when Arctic sea ice went up. Okay? So, that should not cause any concern for you, because that is natural variation. You should look at the long term change. In the long term, the sea ice is declining. Okay? Some years more rapidly, some years less rapidly, some years it is going up. So, you should not let year to year variation bother you and make you think that climate is not warming. Climate is warming, because long term the sea ice has declined. Okay. So, just to summarize this lecture, there is natural climate change occurring due to energy exchange between ocean and atmosphere, which is due to natural causes, which occurs year to year changes. Then human induced climate change, which is changing climate over a long time scale, 10 years, 20 years, 100 years. And then you have local climate change, which is different from global climate change. In local climate change, there can be many reasons. For example, local climate can change due to urbanization. You build more and more concrete jungles, then local climate will change, even when global climate change does not change. Okay? So, the focus of this course will be only on global climate change, because that is much simpler to understand than local climate change. Local climate change is caused by many factors, which I will discuss briefly in the next lecture. So, you must remember that the focus of this course is global climate change, because it is easy to understand, and you should master that first before you start looking at local climate change. So, with this I will conclude this lecture. In the next lecture, we will continue this discussion about local versus global climate change.